Hey guys, today we are going to continue on with z-scores. And so we are going to find the z-score for the data in a set. We're going to start with the normal distribution ones. So remember that z-score, the calculation, is whatever value we're looking at minus the mean divided by the standard deviation. So that's just to assign a z-score, and then we're going to talk about what we're going to do with the z-score next. So one year, many college-bound students took the SAT. For the math portion of this test, the mean was 521. If a student with a score of 350 on the math section had a z-score of negative 0.68, what is the standard deviation? So we're going to use our formula, z equals x minus x bar over standard deviation. So we've got negative 0.68 equals 350 minus 521 over the standard deviation. So if we basically cross multiply, we've got negative 0.68 times the standard deviation equals 350 minus 521, which is negative 171. Then we're going to just divide both sides by negative 0.68. And that is going to give us 251.47. So that is our standard deviation. Seems kind of big, but okay. What would be the z-score of a student that scored 550? So the score was 550 on the math section of the SAT. So we know that the mean was 521. And then we're going to go with the standard deviation of 251.47, and now we're looking for the z-score. So we're going to do x minus x bar divided by the standard deviation. So that should give us 550 minus 521 over 251.47. And that would put their z-score equal to 0.11. We'll go three places, 0.115. Okay, and then what percentage of students are expected to score between 350 and 550 on the math section of the SAT? There are 1,320 students at JHS. How many students would you expect to score between 350 and 550? Okay, so we're going to hold off on this one for just a minute because I don't think we've done that math yet. Let's work on that math. Okay, so we're going to use z-score tables for any time we cannot make just a nice normal curve and label all the parts. So typically what we would have is we would have our normal curve, and then in the very center we have our mean. And as we move over one standard deviation, remember we added or subtracted a standard deviation for each time we moved over. And the z-score is the same as the standard deviation. It's how many standard deviations did we add. So for one standard deviation, the z-score is 1. For 2 standard deviations, the z-score is 2. And for 3 standard deviations, the z-score is 3. And then if we go the opposite direction, the z-score is negative 1, and then negative 2, and negative 3. So the negative just tells us which direction we go on the normal chart. So what we're talking about today is what happens when we don't have a number that's nice and neat on one of our lines, but we want to find the probability of that data point being chosen. So we're going to say that finding the probability, let me write that a little neater, the probability of a particular data point is the same thing as finding the area under the curve. So the total area under the curve is going to be 1, right? Which is the same thing as 100%. So the entire curve is 100%. But what if I don't want the entire curve? What if I just want part of it? So there's steps for each one. So for less than, we're going to find the z-score. We're going to use the table, and I'll show you where the table is in just a second. And then we're going to find the percentage on the z-score table. And the z-score table tells us, say, what percentage is this area here. So it kind of gives us a percentage. So to find something that's more than a z-score, so say to the right of our whatever the z-score is, we would have to find the z-score, find the percentage, but then the key to this is to subtract the z-score from the whole area. And I'll show you what that means in just a minute. But this, so find more than means we have an extra step. And then finally, we can find the area between two z-scores. We basically are going to take the bigger one, find the area for the bigger one, and then we're going to subtract the smaller one. And then we'll find the area in the center. Okay, so I know that made no sense. Let's look at some examples and see if that helps. So the average weight of the NFL player can bench, the average weight an NFL player can bench press is 300 pounds. So our average with a z-score of 0, it's in the middle, is 300 pounds. The standard deviation is 50. So to have a z-score of 1, somebody would have to bench or lift 350. To have a z-score of 2, then they would have to lift 400. And a z-score of 3 would be 450. So the z is just how many standard deviations we left from the mean. And then we'd go the other way, so this would be 250, 200, and 150. And our z-score is -1, -2, and -3. So we want to know what percent of players can press less than 275. So we want to be in this area, and we want to know what percentage of people would be under this curve right here. Okay, but the curve doesn't lay right on a specific value. So first we have to find the z-score. So we're going to do a player can bench 275. We know that the mean, or the x bar, is 300. And we know that the standard deviation is 50. So I just realized I used two different symbols for mean. So this and this are both mean. That's the symbol. So you can use either one. So first we're going to find the z-score. So the z-score is 275 minus 300 divided by 50. And of course we're going to get a negative number because our actual data point is somewhere between -1, which is here, and 0, right? It's between 250 and 300. So when we calculate that, we're going to get a z-score of -0.5. So that is our z-score that we're going to look up. And then we're going to go over percent. So 0.3085. You move the decimal over 2 places and you get 30.85%. So that's the percent that can lift less than 275. All right, what percent of players can lift more than 465? So here's our mean again is 300. We had 350, 400, 450. All right, so this is pretty much off the chart. So we have X is 465, our mean is 300, and our standard deviation is 50. So we're going to do 465 minus 300 divided by 50, and we're going to get 3.3. So 3.3, and I'll go ahead and put 00 on there. 95. Okay, but so that would say 99.95, and that's not right because I'm looking for this area right here, right? Because I want more than. So more than, remember, you have to subtract. So we're going to do 100 minus 99.95, or you could do 1 minus 0.9995. Either one is the same thing. So when I do that, I get 0.0005. So when I do it with 100%, I get 0.05%. That's that tiny little percentage right there. Okay. And then what percent of players can lift between or press between 310 and 410? So here's my 300. So 310 and then 410. So I need to know, like, what is this area in here? What percent of players does that represent? So I'm going to do my 410 first because I want my number to be bigger. So we're going to calculate the z-score for our 410. So 410, the mean is 300. The standard deviation is 50. So we're going to do 410 minus 300 divided by 50. And we're going to get 2.2. So I'm going to go ahead and look up the z-score. So that is 0.9861. Then I'm going to do the same thing for the 310. Oops, x equals 310. And so I'm going to do 310 minus 300 over 50, and that is going to give me 0.2. 0.2. And then let's go look at our, so 0.5793, and then I'm just subtracting. So the z-score here is 0.5793. The one here is 0.9861. So I'm going to subtract those two numbers, 0.9861 minus 0.5793. And when I do that, I get 0.4068. Then I'm going to turn that into a decimal or a percentage. So that is 40.68% of players can press between 310 and 410. Okay, so it's basically just plugging in the formula and looking stuff up on the chart, and let me know what questions you have. Here to our handy dandy table, and we want 0.5. So we're going to look negative. So you have two z-scores. Here's your negative values, and I want 0.5. So here's 0.5. And I really want just 0.500. So this is my number. This is my magic number right here, 0.385. Now 0.385 means, if you look up at the top, it's 0.385 out of 1. So it's all of this side. Okay? 0.385 is the same thing as 30.85. We're going to go to our positive chart, 0.992.2. So I'm going to go to the positive numbers. Score for that is positive. You have positive values and you have negative values. So here's your positive values. And look for 3.3 and go over to 0.0. And we're going to get 9995. So, and And 2.2 is here, 2.20, 0.9861. Positive still. So 0.2 is here, so I'm going to use 0.5793.